Hello students, welcome back to Madhavi's Java programming tutorials. In this video, I'll teach you or discuss the importance of dot operator, counters, accumulators, and also I'll explain you how Java evaluates expressions. Dot operator, counters, accumulators, evaluating expressions in Java, rules of precedence, associativity, hierarchy of operators. Now, dot operator. Dot operator is also known as member operator. What is it? Member operator. This operator either separates or invokes members of a package, subpackage, class, object, methods, and variables. Let's see what it is. Now, dot operator as a separator. It separates packages, subpackages, and class. For example, java.util.scanner. This is a class scanner, subpackage is util, and Java is a package. With the help of scanner class, we take input from user. Then comes, it separates class and object. System.in or system.out, in which system is a class, in and out are objects. So, in these scenarios, the dot operator is used as a separator. Now, invoking members or member methods and variables can be done with the help of dot operator. For example, system.out.println. Println is a method, instance method, means available to the object. Out is an object. System is a class. So, calling or invoking the instance method println is with the help of dot operator. Similarly, invoking static methods of a class can be done with the help of dot operator. For example, math class. Math class has so many static methods. In the next video, I'll teach you how to call these methods. Now, the static methods are available to class itself, not to the object. So, directly we say math.pub means we're calling or invoking static methods. Then comes counters. Very important. These are variables only, but we count the number of times a process or piece of code runs. 1, 2, 3. They are mostly used in iteration. Iteration means repetition of a task. For example, if we want to send invitation cards to 50 different people, we keep a count while sending. So this counter is a variable, keeps counting in the Java language programs. A computer program can be written to repeat a process while keeping a count with for tool. The tool is for. We will learn little later on. For int count is equal to 1, start at 1, count less than equal to 5, count plus plus. This particular for loop or iteration statement repeats the block. How many times? 5 times. Some statements we write print a document or whatever it may be, we write inside that. So this count variable or I variable, j variable, any name we can give, which keeps on counting how many times till we give the condition is met, till the condition is met. When count becomes 6, it stops. Otherwise, count is 1. Is count less than 5? Yes. True, true, true. Till 5 times it is true. When it is false, it comes out. Now the next one is accumulator. This is also we use in iteration. Accumulator is a variable again, which keeps on accumulating the result of addition, subtraction, multiplication, or whatever task. For example, if we need to write a program to read 3 numbers and add them, 3 numbers, that means a counter variable is used to take input how many times? 3 times. It runs the loop 3 times. And we want to add those numbers. So accumulator variable adds the result or multiplication, division, whatever task we want to do. This also accumulator variable we usually use in iteration. Real life example combined with computer programming, although it is very hypothetical. Computer cannot add sugar to our coffee mug, but just see this example. Int mug equals to 0 means inside the mug is a variable. Here real life object, coffee mug is equal to 0. No sugar is there so far. But I am running a loop for starting at 1 to 3. 3 times you do the similar task. What is the task? In the mug, whatever is there, what is there? 0 sugar is there. But add 1 spoon of sugar. Again, second time, add another spoon. Third time, add another spoon. 3 times this process will be repeated because of our iteration, and mug is a variable, coffee mug, which is accumulator. Which is accumulator. Adding, keep on adding something to it. Then, evaluating expressions in Java, very, 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 very important. First of all, we should understand what Java is doing for us. And then we guide the compiler to give output according to our expectations. Now, evaluating expressions. Programmers write programs for various fields, maybe physics, maths, chemistry, which may use mathematical expressions. Now, expression is a collection of operands and operators. For example, int a is equal to b plus c into 4. We have used 2 arithmetic operators, plus and multiplication. Equals to is an assignment operator. In the second example, if a plus b greater than b plus c and a not equal to b. In this, arithmetic operators are there, relational operators are there, logical operators are there. The concept of different operators is explained in the video Operators. Link is given in the description box. If you want, please go through. Now, Java uses the following rules. Automatically, it does so much work for us to evaluate expressions. First of all, it follows rules of precedence, that is priority of operations. Second one is associativity, order of operations, either left to right or right to left. Rules of precedence. This concept specifies that the operators with higher precedence will be evaluated first, followed by operators with lower precedence. For example, arithmetic expressions. Every one of you know BODMAS. Brackets of, in Java we use exponent. Brackets has the highest precedence, priority. Then exponent. Then division, multiplication, both of them have the same precedence. But the priority is given to whichever operator is used first in the expression. That too from left to right. And then fourth precedence or fourth priority is given to addition or subtraction, but both of them have same precedence. So the priority is given to similar to division multiplication, that is left to right, whichever operator comes first. For example, with the help of three examples, we'll understand this. 5 into 6 plus 7. This is very easy. 5, 6 are 30. 30 plus 7 is 37. But 7 plus 5 into 6, if you see, according to BODMAS, multiplication and division have the higher precedence than addition subtraction. So 5 into 6, 30 will happen first, and then 7 will be added. The answer for first and 2 is same, because 5 into 6 plus 7 or 7 plus 5 into 6, one and the same. So Java is doing it for us. In the third expression, 5 plus 6, BODMAS, brackets are there. So first of all, 5 plus 6, that is equal to 11. 11 7, that's 77. So utmost priority for parenthesis. Hierarchy according to the precedence. Although I haven't explained accessing array, declaring array, the highest preference is given to that square brackets operator. This precedence is not simple serial number. It is the priority given. First priority, square bracket. Second priority, dot operator. Third priority, method accessing, which we will understand little later on. Unary operators, fourth priority. Typecasting, arithmetic operators, that too using BODMAS. Relational operators, only greater than equals to, or less than equals to, less than or equals to. Then comes 8th position, equality, inequality. 9th, logical AND. 10th, logical OR. 11th, ternary. 12th, assignment, and many more are there. I am giving mostly the ones which are explained and important, very important. So by looking at the precedence, let's understand one example here. Int a is equal to 5, b is equal to 3, c is equal to 2. Let's suppose a small program. Boolean d is equal to a plus b greater than b plus c and a not equal to b. This expression, by looking at the operator precedence, the Java will execute like this. We are just understanding. Now, a plus b, arithmetic operator. If you see the list, arithmetic operator is in 6th position, 6th priority. Okay. Greater than, there is one greater than. Okay, 7th priority. So 6th is higher than 7th. And then and, that is 9th priority. Then a not equal to b, 8th priority. So we will understand, the Java understands. First of all, I have to evaluate arithmetic operators, that is 6th priority. Then relational, because 7th priority. Then inequality operator at the end, that is 8th priority. Then comes logical AND, that is 9th priority. So in our way of executing, first is arithmetic, second is relational, third is inequality, fourth is logical AND. So there are two arithmetic operators, a plus b, b plus c. A plus b, a is 5, b is 3, so 5 plus 3 is 8. B plus c is 5. So we got numeric value after arithmetic operators, intermediate values. Now the relational operators on a plus b greater than b plus c. A plus b is 8, b plus c is 5. Is 8 greater than 5? Always relational operators return true or false. Recall that video. So 8 greater than 5, true. Then inequality operator we have seen from the list. A not equal to B. A is 5, B is 3, not equal to B returns true because it is a relational operator. Now these two will be clubbed with logical and. And means both of them true, then only it gives true. So first expression is 8 greater than 5 true and A not equal to B true, true and true, answer is true. This much Java does. But still, as a programmer, you may little bit change using the parenthesis operator. We will see little later on. This is how Java evaluates expression. Not only this, associativity. Why? Because see, Java evaluates expressions by considering rules of precedence and also associativity. Associativity means order of execution of the operators. There are two forms, left to right, right to left. In the previous example, we have taken Boolean D equals to. Equals to operator has the least preference in the previous video. So, sorry, in the previous slide, look at this slide. Here, Boolean D equals to A plus B greater than B plus C and A not equal to B. This much we have done true. But assignment operator, that is equals to, has the least preference. And associativity also we will discuss. So, first of all, this entire thing will be evaluated and then stores true in D. D is a variable of Boolean type. Now, associative means order of execution of the operators. There are two forms, left to right or right to left. Left to right means first operator, then followed by second, third, n using BODMAS, and also hierarchy of operators. Then right to left, start from n, go back to 1 using BODMAS and hierarchy of operators. Now associativity of arithmetic operators is from left to right. Associativity of assignment operator and all shorthand operators is from right to left. That means int A is equal to B plus C into D. That is the expression. This is left to right. B plus C, D arithmetic operators. So first of all, B plus C into D will be evaluated. And then equals to is from right to left. So equals to this evaluated at the end. So the answer will be stored in A at the end because the associativity is from right to left. Now look at this. It is difficult to remember all these rules because Java is doing so much for us. But still, there might be some ambiguity. For example, see the roots of quadratic equation. X is equal to minus b plus r minus b square minus 4ac under root whole divided by 2a. So the programmers, if it is doing b square minus 4ac, okay, b into b, it has multiplication, higher precedence than minus. So instead of doing all these things, what we do is, we use parentheses and take some intermediate variables. Double SQ is equal to B into B minus 4 into A into C. We have done that. SQ has the value. Now, math.sqrt, SQ, square root of that B square minus 4AC. Now we have to do minus B. There will be two roots. Minus B plus square root whatever it may be by 2a and minus b minus square root of that b square minus 4ac by 2a. Here ambiguity arises. If, see the comments, minus b plus sq divided by 2 into a, if I write without parenthesis, what happens? It will see minus, plus, division, multiplication. Okay, division, multiplication have the higher precedence, so whichever comes first. So s cube by 2 will happen first. And whatever the answer into a will happen. Then only plus and whatever minus b. But this answer would be wrong because whole divided by 2a, the computer does not know this. So minus b plus whatever square root we put in parenthesis. This whole should be divided by within brackets 2 into a, this whole. So we need to guide after understanding associativity and precedence. Then hierarchy of operators with associativity is like this. You know this 1 to 9, square bracket, same operator list I have given. But associativity for unary operators is right to left, typecasting is right to left, assignment and shorthand assignment operators is from right to left. Refer chapter 4, Basics in Computer Applications for the complete list of hierarchy of precedence and associativity. Chapter 4 has all these things, counters, evaluating expressions and examples. So please go through. The next video is about calling different members of a class in main method of Java. Thank you.